Newton's law of universal gravitation calculations usually come in two forms. The simplest is where you are given the mass of two objects and the distance between their centers and asked to calculate the force that exists between them. Obviously, when doing those calculations, it's important to remember that in physics, masses must always be converted into kilograms, and the distance between their centers must always be measured in meters. This is a common stumbling block where distances are often very large and they're given in kilometers, and you must remember to convert it before substituting into the equation. We know that forces are always measured in newtons, and Newton's gravitation constant has the units Newton meters squared per kilogram squared. However, the far more common way of asking these questions is in the form of a proportional change. So you are told that there are two objects, m1 and m2. They are initially a distance r apart, and there exists a force F between them, or we can call it F0 or F original, which is just the formula as it's given. And then there are changes that can be made to the setup, and then they ask how the force changes. So the simpler change can be a mass change, where they say, in this example, the mass of m1 is halved and the mass of m2 is tripled. What is the new force? And what you would then say is, you would say, well, the new force is going to be, once again, Newton's universal gravitation constant, but now it is 1/2 times m1, because they've said m1's mass is halved, and 3 times m2, because you have been told that m2's mass has been tripled. The distance again remains the same because nothing has been said about that. We can then simplify that to find that we can take out a fraction 3/2 times m1 m2 over r squared. What then allows us to see that this over here is the original force and can be substituted with that. So we get a final answer that says to us that the new force is equal to 3/2 times the original force. The second and slightly more complicated change is a separation change. So now what they say is that these two objects, once again originally a distance r apart, with masses m1 and m2, have a force F0. Calculate the new force if the distance between their centers is halved. And you follow the same setup. New force is equal to g, m1 and m2 remain unchanged, but now we need to remember that the distance between them must always be squared, so it's in brackets 1/2 times r squared, which we then can simplify by squaring it to find that that gives us 1/4 r squared, which we can simplify once more, which gives us 4/1 g m1 m2 over r squared, which again shows us that this is our original force once more, which tells us that the new force is 4 times the original force. And this once again supports the inverse square law that tells us that although we've only halved the distance, we have actually made the force 4 times bigger.